Thank you very much for being here. My name is Tara. Quick question. Who runs on EE here on mobile or at home? Nobody? Oh, okay, couple. Yeah, I have some spoiling news for you. You're running on OpenStack infrastructure. Okay, so I'm Tara. I've been around in open source for a while. I came from in BT in the recent 4 months, and I work with the cloud team. And with me, the Serdar.
Hi guys, I'm Serdar. I'm with Canonical. I'm a product manager at Canonical. Been just over 3 years now. It's great place to work as an open source company essentially, and we work close with BT for the infrastructure projects. And today essentially we're here to talk about open source, all open source, rather than monolithic infrastructure deployments, and how that changes the telecommunication networks in production, not only on proof of concept deployments or so to say like theoretical future-proof things, but it's actually solid market-driven deployments today. Thank you.
So, before going into the days, I have dual role here because I'm both the head of open source at BT and I'm a member of community. So we'll try to balance between the two. Of course, in the Q&A section, I will be more flexible about getting questions about the community, my community side. Okay, but here let's talk about BT. So the thing is that I believe it was 2020, something has changed in the telecommunication landscape, and that forced many telcos operators, including BT, to rethink about how do we restructure our mobile network. And this is specifically for the mobile network infrastructure, how we restructure our own mobile network infrastructure. And of course, we did need something that has to be dependable, trusted, and deliver high performance. I mean, I guess you all want to see your latest TikTok video on the 5G network, so it has to be quite quick. And we had to comply with rules, especially lately with the latest Ofcom compliance rules that are enforced in the UK, which are, in my personal opinion, they don't make sense, but they actually need to be, you need to rethink the way you access your own infrastructure. And this is actually, I have mixed feelings about explaining this because I've been a consultant for 30 years, so I know a bit of background of a lot of people about this. So the thing is that a lot of people, and I've seen as a personal, in my personal previous life, even telco operators move into the public cloud. But in that specific case, decapsulating IP packets into the public cloud is not that cheap always. So many, including BT, decided that actually it's not worth the cost. I mean, public cloud is fine if you want to, they call it dev-heavily use case. I mean, if you develop a lot, tried a lot of things, you remove infrastructure, especially if you use infrastructure as code, and then you deploy something in production, but the production is actually not that expensive. It's more the development side that is expensive. We list in many companies, and including this specific use case, running it in private cloud would be less expensive than in the public cloud. And do I really need to explain this? Why open source? I mean, it's so much more flexible to run on OpenStack, in open source infrastructure. 20 years on OpenStack is actually, of course, I mix it up. And we will, as you can imagine, we run a lot of software and a lot of our on services like and DNS proxy is caching, a lot of caching, and a lot of things that have to be integrated. So what is something that is actually most open and most integrated, that can be integrated more easily than the open source? So back to you.
Thanks very much, Tara. So I'm going to talk about a little bit about what our target was when we built this infrastructure, essentially. You can see like some bullet points about like general goals here, and they're pretty much what you would want to see in a telecom infrastructure. You would want a scalable infrastructure because obviously when you have a converged infra and with a high demand that also has variable and dynamically changing patterns of traffic over a large area, you would want this to be as scalable as possible across different cloud locations. So you would want to therefore disaggregate your different parts of your infra, the compute, the storage, and you need to control them separately as much as possible. That scalability also, apart from that, there's the flexibility side of things, where you would want to manage your infrastructure flexibly, its resources flexibly, starting all the way from its bare metal infra up to the virtualization layers. And of course, if you're operating a critical infrastructure, you need to be as resilient as possible to any cross-interference between the applications running on top of that and also the infrastructure itself. So you would want to have that as a must. And of course, when you deploy an infrastructure, it's always a question as to how costly that will be in deployment time and operation time. And you would want to always find the ways to make it as cost efficient as possible. And one way to do that is automation and low-touch operations. So that was actually a goal, of course, in deployment and configuration, and also runtimes as well. And finally, of course, it has to be performant, highly performant. So you would want to have as many locations as possible that leverages what the hardware can offer in the best possible way. But in doing so, you would want to have those optimizations for all the workloads that you run in your telecom networks. And for that, obviously you would want to have, I talked about when I started talking about this, like you don't want any monolithic infrastructure. It has to be composable. That composability comes from how beautiful open source is, how interactive that you can be, how imaginative you can possibly be with that. Different ways to configure that is depending on your needs. And of course, there has to be a stack that needs to be a composable stack, and exactly what our purpose was when we built this infra. And that starts from all the way from hardware. So you would want to make as much optimization of your software stack on top of your hardware, your silicon, your servers. And that comes with also a bit of automation there as well. Not bit, actually, as much as possible, so you can achieve those low-touch operations. That comes with the bare metal management with metal as a service, MaaS. And then there's also a layer of system management. So when you have a distributed network, you have many Ubuntu servers running everywhere. As you would want to have a way to manage that fleet, manage the way to configure that, a way to update and patch in real time. So that came with landscape, the system management. And of course, to run different virtual machines and multi-tenant environments, OpenStack is the star of that stack in that sense. But it needs to also have the virtualization behind that. For example, control of your storage arrays. And that's where Ceph plays a fundamental role in controlling centrally and distributedly. And it also has the beauty of adding new nodes as you need more storage. And it provides that to OpenStack services like Nova and Cinder and Glance for all storage needs like object storage, block storage, image storage. And of course, OpenStack has services. There's a control plane. Those control plane services need to run in as coherent as possible and not interfere with each other because they're working the same infra. Their LXD plays a central role because it provides them the container environments to run those control plane services.
Yeah. Okay, so as I said, when it came to BT, it was actually very strange for me because I've been doing this been installing OpenStack for 15 years all over Europe and the US, and I've never seen such a massive amount of OpenStack installations. We have roughly more than 50 OpenStack installations, and when I said OpenStack installation, it means control plane and compute planes, which is kind of unique because I've been around, and even if they have massive OpenStack installation, the control plane is there's not many OpenStack instances. There are many thousands of compute nodes, but here we're talking about 50 OpenStack installations. They're not easy to manage. One of the most difficult tasks in OpenStack is upgrading OpenStack. So imagine how this has become very important to be automated. And I can't thank you enough, our automation team, but we will speak about this later. So 50 OpenStack installation in the exchanges where your mobile core is actually terminated. And what we do on OpenStack. So these are examples of workloads that we run. What we do is that we provide what we call internal tenants, internal customers. We provide what is an OpenStack is called a tenant, and they can build their own architectures. One of the architectures called, of course, is the mobile broadband, is where our 5G control plane and user planes are run. So this is where when you actually browse from the or you use your phone is actually terminated. We have partially some fixed broadband utilities. I'm trying to mediate whatever I can tell and not tell. But for example, here are the caches where when you browse the internet, for example, the updates of the iOS are held to save some bandwidth. We have, of course, some security tenants where we identified frauds and security threats. And what, for example, another thing is called, by the way, I forgot to say, sometimes we mention network in telco sense. So it's not IP network, it's telephone networks. Might runs on IP, but that's a different story. And one of the things is that we run the intelligent network on top of OpenStack as well. Intelligent network, which means telephone routing, for example, or voicemail. And one of the things that, if you come from a telco operator, you usually go to a vendor and buy the full stack. So you go to whatever brand and say, I want 5G, and then they give you the full stack. But it's not very efficient, especially when it comes to security and enforcing the policies or observability. So what we say but somebody else has to get credit for it. And we consolidated it in a single infrastructure, and that would be OpenStack. And gives the flexibility of basically consolidating everything. And as I said, 99% of the traffic runs what we call the network cloud. So we are very proud of it, and there's somebody in the audience that should have been credit for this success. And we had and this person actually won the Cloud Excellence Award 2024. Thank you, Claire. One of them was what is called the most innovative cloud product of the UK. And this slide says what's next for us, but actually a few of these projects are already running. I mentioned about automation. So what you saw on a site is fully automated. You press a button, mostly press a button on a CI/CD, and a new site has been built from scratch. And it is an amazing thing because we set up, for example, mass first. We bootstrap the mass then bootstrap the other nodes, and then we set up from there. And that has been all automated by the amazing automation team that we have. For example, Kubernetes, we are already offering Kubernetes container as a service in a limited production at the moment. Testing, automation, during the automation process, for example, we do some basic at the moment automation testing, like firing up a VM and see reachability, which is not given for granted because, for example, we have a lot of network policies inside. So how do you automate this? This is a huge amount of effort. And environment as a code is a kind of given for granted now with Terraform. I should say OpenTofu now. As a code, we have a lot of them. There is some templates as well. And we are looking at the other things. I cannot talk about that much. But back to you.
Thanks a lot. So there are obviously some pillars of principles that you would need to follow when you deploy a private cloud, especially for dev-heavy workloads. Well, you want to have that cost efficiency because that's why you kind of run away from public clouds. So you can run those costly operations that you would always be operating all in a while. So cost efficiency, cost effectiveness was fundamental pillar there. You also want to have easy operations, easier to deploy, easier to maintain, easier to provision. That's why you have all around the stack all the automation layers that you would need, all starting from bare metal. And of course, every layer, like in a telecom network, you would want reliability because you want your network to run all the time without interruptions. And also you want security in place because with any software, of course, you have large attack surface. You would want to make sure that every software component gets patched and timely manner, and those dependency trees are all secure in an automated way, not manual processes. And there, basically, we see that people love Ubuntu. They love the experience with Ubuntu. And what we wanted to do is expand the same principles that Ubuntu brought to the community into a stack of solutions around open source. So that's our main agenda, essentially, to bring open source, production grade, stack composable, so not monolithic. So you would be able to basically program your automation framework around it if you wanted to, because APIs are open, source is open, so that brings transparency to you. So from the stack, from bottom to up, you would have that open source composable infrastructure. And according to use, you can shape the way you want. Of course, I talked about Metal as a service for provisioning before, but there are other projects as well, such as OpenStack and Kubernetes, which are obviously worldwide global projects with a wide community behind them. And our agenda is to make them production grade with our security coverage in place. That means like all the packages that make up these open source projects are actually patched in real time. And on top of that, you would need to have some sort of course, like you have a variety of companies who want to deliver new solutions, innovative solutions, on top of an open source infrastructure. That means that you will need to have a framework around how you would deliver those applications in an automated way, in a secure way. Can I actually use the same principles so that they feel empowered? So that's also in our agenda. That's why we also penetrated into application space, making those applications such as you can see in databases and tool changes for AIML, for example, just to name a few. But there's a wide range of applications that you would see they are being supported now. They're being patched for security vulnerabilities in real time. And also, you know that they will deploy and run smoothly. Because in many times in operations, you would see that, hey, there is an open source software. I want to run this software because it's cost efficient, of course. You don't have licenses for it. But at the same time, it's so difficult to deploy. It's so difficult to operate. How do I get away from all that barriers? And that's our entire agenda, essentially, at Canonical. We want to make sure that open source is consumable, it's production grade, and runs smoothly, and patched and supported. And of course, that long-term support process now across the stack of these layers, the software layers that runs on top of the infrastructure, now also penetrates into containers, because containers are incredibly popular, right? And you have developers building Docker images today. And those Docker images, they have their own recipes. So every developer wants to achieve something with that. They come up with their own ingredients in that. There is open source that penetrates into that in different ways. So you would want to build an application that comes with its dependencies as well. Now, what we do in Canonical is essentially provide that long-term support to those customized Docker images as well, which we call Everything LTS. With Everything LTS, you have many benefits. Like one of them is always that long-term support for your software infrastructure and applications with CVEs patched. But at the same time, you have this composability. So you have a essentially a customized Docker image, which is now supported as well. But it also deploys on multiple platforms, not only Ubuntu, but other Linux distributions as well. That gives you a lot of freedom as well. And of course, there's a story about compliance, because there's a lot of security compliance standards you need to comply to, such as FedRAMP, FIPS, and so on and so forth. And that, of course, like helps the open source developer community, because it's massive. There are hundreds of thousands. I even forgot the number now. Also, so many zeros there. So hundreds of thousands of packages, millions of containers, and the operators that come with them, so that you can have a smooth experience with them. If you actually support that community of developers, you empower the open source, you empower all the companies behind open source, which means you actually act as an incubator for the wider community. And of course, like this is a cycle. It's not just like basically I develop my software and it's gonna be fine from there on. Of course, we all know this, because as any software, you have dependencies, and there's a build life cycle starting from the initial stages all the way to updating, optimizing its dependencies, maintaining that. And if something changes, you would need to rebuild them in runtime. You would need to operate it. All of this is vulnerable because you run with other software, right? So that comes with like a change in the CVE dependencies. Oh, this is going to affect the other software. So you need to have a mechanism behind this to automate this patching, and this is exactly what we bring to the community.
Okay. So let's go if you have any questions, and thank you very much for FreeBSD sticker. I was actually in the FreeBSD room here.